So in this question, we're given that 2 to the power of x multiplied by 4 to the power of y is equal to 1 over 2 root 2. And what we're being asked to do is to express y as a function of x. So what we want to do here is we want to perform some operations on this expression to isolate y, and then to have an expression where y is equal to something, where that something contains an x at some point. So taking a look at what we have, we first think about indices and index laws. We know the following index laws, and we have that if we have a to the power of m multiplied by a to the power of n, that is going to equal to a of m plus n. So therefore, looking at what we have, we see that we have a 2x and a 4y. If we keep our 2x, but we know that 2 squared is going to equal 4. So if we write this, so if we take this term here and we write that as 2 to the power of 2y, these two things are equivalent. And then here we're going to write 1 over 2 root 2 in a different form. So we have 1 over 2, and then we know that root 2 is going to be equal to 2 to the power of a half. And then we have 2 multiplied by 2 to the power of a half. Then what we can do is we can apply this index law to the left hand side here. So we'll therefore have that 2 to the power of x plus 2y is going to be equal to 1. And then we divide that by 2 to the power of 1 multiplied by 2 to the power of a half, which is going to be equal to 2 to the power of 3 over 2. Since we know that 1 plus 1/2 is going to be equal to 3 over 2. So then we also have the following index law. We know that 1 over a to the power of m is going to be equal to a to the power of minus m. So we can therefore use this second index law on this term here, so we can get rid of the denominator. So we're therefore going to have our left hand side stays the same. So 2 to the power of x plus 2y is going to be equal to 2 to the negative 3 over 2. So now we have an expression where we have 2 to the power of something and 2 to the power of something. So we know that this then means that if we have a to the power of m is equal to an, then we know that m is going to be equal to n. So therefore, taking this back to what we have 2 to the power of something and 2 to the power of something. And we can see both these exponents highlighted here in yellow. So we can therefore say that x minus 2y is going to be equal to negative 3 over 2. We can then rearrange this, and we'll have that 2y is going to be equal to negative 3 over 2 minus x. And then dividing everything by 2, we have that y is going to be equal to negative 3 over 4 minus x over 2. And therefore, we have found an expression for y and have completed the question. So taking a look back, we knew that this question was worth 3 marks. So we received our first mark for knowing to use the first index law. So we used that. When we went from 2 terms into combine them into 1 2 term, where we added both the exponents. We then receive our second mark for using the third index law here. So a of m is equal to a of n, then m is equal to n. So we use that to go from this step to this step, and that's where we received our second mark, and we received our third and final mark for going from this stage here down to our final answer, where we received our third mark. So in this question, we're told that the speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. And here we're given a table which show the results. We have the time and the corresponding speed, all the way from time is equal to 0 all the way to time t equals 25. So for part A of this question, we're asked to estimate the length of a runway used by the jet to take off. So here we can imagine that we have a graph, And our graph is going to look a little bit like as follows. So as you can see here, we have a graph of speed against time, where we've plotted each point t against each point s. So you can see here that as the time increases, the speed increases. And we can see that as the time increases, the speed changes by more. So we can see this by the steepness of the line changing as t increases. So we know that to find distance from a speed time graph, we can use the area. And we can do this by splitting it up into trapeziums. And then we find the area of each trapezium and sum these to find an estimate of the area, which will be equal to the distance of the runway. So how do we do this? So we're going to use the trapezium rule, which is given here by the formula in the yellow highlighted box. And to work out this estimate for the area, we're going to split our graph up into trapeziums. So we're going to first split it into strips, and h is going to be the width of each strip. So as you can see here on the graph, I'm going to drop a dot down at each point, and we can see that this is the difference between each time interval, and the interval that these are being measured in is 5 seconds. So therefore, we have that h is going to be equal to 5. We then have that y0 is our initial value, and then we'll have y1, y2, y3, y4, and y5. So we now have the values that we need to then use our formula. So we'll have that the area is going to be equal to 1 over 2 multiplied by 5. Then we'll have our big brackets, and we're going to have y0, which is 2, and we're going to add that to y of 5, which is 42. And then to that, we're going to add 2 lots of y1 plus y2 plus y3 plus y4. So that will be 5 plus 10 plus 18 and finally plus 28. We then put this into our calculator and we get that the area is going to be equal to 415 meters. So then this means that we can conclude that the length of the runway is going to be 415 meters. So we now move on to part B of the question, where we're asked to explain whether your answer to part A is an underestimate or an overestimate of the length of the runway used by the jet to take off. So to answer this question, we're going to take a look at our graph. So we've used the trapezium rule, and what we need to think about is this going to overestimate or underestimate the area. So what do we mean by overestimate or underestimate? So in this graph here, if I just take a look at this interval between 5 and 10, and what I'm going to do in green to highlight this, I'm going to show what an overestimate and an underestimate of the area is going to be. So if I draw a green dotted line in here, this green strip here, that will give an underestimate of the area of this whole bit here. But then if I then do the same in purple and measure this, and then work out the area of all of that, that is going to give an overestimate. So now I need to have a think about what is a trapezium. And I'll illustrate that on this final column here. So let's drop these down just like that. So then now we'll have a think about what this means for us. So we know that in practice, this curve is actually going to be curved and it's going to be concave. So the last part is going to look slightly like this. So then we know that this straight line here is greater than where the point along the graph is. So this means that we'll have extra area in between these two, which results in us overestimating the area. And this is because we have a concave upwards graph. So writing this down, we use the trapezium rule, and we have a concave upwards graph. So we therefore have an overestimate, since the top of the trapezium is over the curve. So now we'll take a look and see where marks were on offer in this question. For part A of the question, there was 3 marks on offer, and we received our first mark for knowing to use this formula here and knowing to use the trapezium rule. We then received our second mark for using this successfully and getting to the stage where we had identified what h and all of our y's were, so that is this stage here. And then we received our third and final mark for computing this in the calculator and concluding that the length of the runway is 415 metres. Then moving to part B of the question, there was 1 mark on offer, and we got this 1 mark for stating that we had an overestimate. So in this question, we're shown figure 1 here, which shows a sector AOB of a circle with centre O, and we can see that the radius of this circle, or this segment, is going to be 5 centimetres, and the angle AOB is going to be 40 degrees. So we're given the attempt of a student where they have attempted to find the area of the sector, and that is given to us in this box here. So just quickly, we can see that they have a formula to work out the area of the sector. They then substitute in their values and then come to a conclusion of 500 centimetres squared. So in part A of this question, we're asked to explain the error made by this student. So we can see the formula that they've used. They have used that A is going to be equal to 1 over 2 multiplied by r squared multiplied by theta. We know this is a valid formula, but it can only be used when our angle is in radians, but our angle is in degrees. So we'll just write that down. So this is valid for radians. So therefore it's used incorrectly in our case because we have degrees. And the student doesn't convert it to radians. And we know that the correct formula that we can use to work out the area of a sector of a circle is as follows. It's going to be the angle in degrees divided by 360 multiplied by pi r squared, where we know that this part of the formula is converting our angle from degrees to radians. Now moving to part B of this question, we're asked to write out the correct solution. So we'll do that as follows. We'll have that the area of the sector is going to be equal to the angle, and we divide that by 360 and we multiply by pi r squared. We have that our angle is equal to 40 degrees and our radius is equal to 5 centimetres. So therefore, substituting all of this into our equation, we have 40 divided by 360, and we multiply that by pi and then by 5 squared, and then putting this into our calculator, we get that the area of the sector is going to be equal to 25 pi divided by 9, and this is approximately equal to 8.73 centimetres squared. So now we'll take a look and see where we gained our marks in this question. So part A, where we had to explain the error made by the student, is worth 1 mark, and we received 1 mark for having 1 correct point of explanation as to why the student was wrong. And then for part B of the question, it was worth 2 marks, and we received our first mark for substituting our values here into our correct formula. So this is where we receive our first mark, and then we receive our second mark for coming to the correct conclusion. So putting them into our calculator and then coming out that the area is equal to 8.73 centimetres squared, or 25 pi over 9. And either of these answers would have been acceptable. So in this question, we have 2 curves. So we have curve C1, which is given with parametric equations. X is equal to 10 cos t and y is equal to 4 root 2 sine t. And we can see this here on the diagram, a kind of ellipse shape. And then this meets the circle C2, which has the equation x squared plus y squared is equal to 66. And this is in the standard form of an equation of a circle. And we can see that these 2 circles meet at 4 distinct points. And we see on the graph they are 1, 2, 3, and 4. So what are we asked to do? We're given that one of these points, S, lies in the fourth quadrant of the graph. So this means that it's in this section here. That's what the fourth quadrant means. And what we're asked to do is to find the Cartesian coordinates of S. So where it lies in relation to the origin. So how are we going to do this? So let us start off and write down what our equations are. So x is equal to 10 cos t and y is equal to 4 root 2 sine t. And then we have our second circle, x squared plus y squared is equal to 66. So our first step is going to be substitute x and y from circle 1 into circle 2. So we'll substitute circle 1 into circle 2. So this will give us 10 cos of t all squared plus 4 root 2 sine of t, and then we square all of that, and that's going to be equal to 66. And then squaring this, we'll have 10 squared, which is 100 cos squared t. And then we know over here that 4 root 2 squared is equal to 32. So therefore we'll have plus 32 sine squared t. And this still is equal to 66. So now we want to solve this equation for t. And we know that we can't solve an equation easily when we have cos's and sines. So we're going to note that sine squared t plus cos squared t is equal to 1. So rearranging this, we have that cos squared t is going to be equal to 1 minus sine squared t. So what we can do is we can substitute 1 minus sine squared t into this equation here for cos squared of t, and then this will leave us with only terms which have sine in them in the equation. So therefore we'll have 100 lots of the expression we want to sub in, so 1 minus sine squared t, and then we'll add on 32 sine squared t, and that's still all equal to 66. So our next step will be to expand these brackets here, and that's going to leave us with 100 minus 100 sine squared t, and then we'll add 32 sine squared t, and that is still going to be equal to 66. So now what we can do is we can add together our sine squared t terms and then subtract 100 from both sides. So this is going to leave us with 68 sine squared t, and that is going to be equal to 34. Next we can simplify this slightly, and if we divide everything by 34, we'll have 2 sine squared t is equal to 1. And then dividing again by 2, we'll have that sine squared t is equal to 1 over 2. And then we can get rid of the squared by square rooting both sides. So we'll then have that sine t is going to be equal to the square root of 1 over 2, which is going to be 1 over root 2. And we know that this is now in a form in which we'll be able to solve. So we can therefore write that t is going to be equal to sine to the negative 1, 1 over root 2. And then putting this into our calculator, we get that this will be equal to pi over 4. So then referring back to the question, we were being asked to find the coordinates of S. So we know that this is going to be in the form x and y. So recall that we have two equations. We have an equation for x, which is 10 cos of t, and we have an equation for y, which is 4 root 2 sine of t. So what we can do, we now have a value for t, so we can substitute this value of t into these equations for x and y, and that's then going to give us our coordinates. So we'll have that x is going to be equal to 10 cos pi over 4. And putting that into our calculator, this comes out as 5 root 2. So that means the x coordinate is going to be 5 root 2. And then doing the same for y, we're going to have 4 root 2 sine pi over 4. And we put this into our calculator and it comes out with 4. But then looking at our diagram again, we can see here that we're looking for s. And we know because of the symmetry above and below the axis that these points of intersection are all going to have y coordinates either positive 4 or negative 4. So therefore we can see that s, the y coordinate, is going to be negative 4 since it's below the y axis. So therefore our coordinate y equals minus 4 since s lies below the axis. So then to write a concluding statement, we're going to have that s is going to be equal to 5 root 2 comma negative 4. And that's how I solve this question. So this question was worth 6 marks. And we pick up our first mark for knowing to substitute the parametric equations for circle 1 into circle 2. And we pick that up here. We then receive our second mark for identifying this trig identity here and how it's going to be useful to help take us forward. And then we receive our third mark for substituting that into our equation. We then receive our fourth mark for getting to this stage here. So where sine of t was equal to 1 over root 2. And we then receive our fifth mark for solving this and getting pi over 4. And then we receive our sixth and final mark for substituting in our t value into our x and y equations and concluding that the point S has coordinates 5 root 2, negative 4. So in this question we're shown the following graph in figure 3, and it shows a sketch of the curve with the equation y is equal to the square root of x. So we can see the curve here as y equals root x, and we're told that we have a point P of xy, which lies on the curve here. We then have a rectangle, which is shaded, as we can see here, and it has a height of y and a width of delta x. We're asked to calculate the limit as delta x tends to 0 of the sum from x equals 4 to 9 of the square root of x delta x. So effectively what we're being asked to do is, as this delta x here gets really small towards 0, what is the area between 4 and 9? So we know that we can work out the area by integrating. And we know that the definition of the integral is going to occur when, in this case, delta x tends to 0. So therefore, since delta x tends to 0, we can say that the limit of delta x to 0 of the sum from x equals 4 all the way to 9 of the square root of x delta x is going to be equal to the integral of root x with respect to x. And now we ask, what are our limits going to be? Well, we're summing from 4 to 9, and then also we can see in the graph the area goes from 4 to 9. So therefore we'll have our limits as 9 for the upper limit and 4 for the lower limit. So therefore, continuing this on, we know that we can express the square root of x in a slightly nicer form for being able to integrate. So we'll have that the square root of x is equal to x to the power of a half, and we're still integrating with respect to x. And then from our knowledge of integration, we know that we add 1 to the power and divide by the new power. So that leaves us with x to the power of 3 over 2. So then we divide by 3 over 2, which is equivalent to multiplying by 2 over 3. So therefore we have a 2 in front of the x, and this is all divided by 3. And then we're going to put our square brackets around it here and write in our limits still. So 9 and 4. And then all that's left for us to do now is to take 9 and to take 4 and substitute them into our equation. So what do we have here? We're then going to have 2 lots of 9 to the power of 3 over 2, and we're going to divide that by 3, and then from this we're going to subtract 2 multiplied by 4 to the power of 3 over 2, and we're going to divide this one by 3 as well, and then putting these into our calculator, these come out as 38 over 3, and therefore we've answered the question, and we've shown that the limit as delta x tends to 0 of the sum from x equals 4 all the way to 9 of root x delta x is equal to 38 over 3. This question was worth 3 marks, and we pick up our first mark for knowing that this expression here is equivalent to this integral here. So we gain mark 1 here. We then gain our second mark for successfully integrating the square root of x and getting to this stage here with our square brackets and our limits here and here. And then we receive our third and final mark for correctly substituting our limits into this expression and coming out with the correct answer of 38 over 3. So in this question we're given a function g of x, which is a piecewise function which has 2 different parts depending on what the value of x is. So for x less than or equal to 2, we have that g of x is going to be equal to x minus 2 squared plus 1. And then for x greater than 2, we're going to have 4x minus 7. And we can see the graph of it is shown here with a straight line for the 4x minus 7 part, and then a curve for our x minus 2 squared plus 1 part. So in part A of this question, we're being asked to find the value of g of 0. And this means that we need to take our function g of x and work out our first g of 0, and then work out what g of 0 is. So this is called composition of functions. So we first want to note that when we have g of 0, we know that x is equal to 0, which is less than or equal to 2, which means that g of x, for this case, is going to be equal to x minus 2 squared plus 1. So then what we can do is then say that for g of 0, this is going to be equal to, we substitute in 0 for x, so it's going to be 0 minus 2, and we put brackets around that and square and add 1, and then this comes out as 0 minus 2 is minus 2, squaring that we get 4, and then we add 1, which is 5, so we have that g of 0 is equal to 5. So then for the next part of this question, what we need to do is do our next composition of something. So we have then that g of 0 is 5. So in effect, we're now going to be working out what g of 5 is. So we have that x is equal to 5, which is greater than 2, which means that g of x is going to be equal to 4x minus 7. So then writing this, we'll have that g of 0 is going to be equal to 4 lots of g of 0 minus 7, which is going to be equal to 4 lots of what we worked out g of 0 as, which is 5. So we'll have 4 lots of 5, then we'll take away 7, and we know that 4 lots of 5 is 20. We subtract 7, which leaves us with our final answer of g of 0 is equal to 20 minus 7, which is 13. So now for part B of this question, we're asked to find all the values of x for which g of x is greater than 28. So we'll recall here that we'll have that g of x is our piecewise function, which will be x minus 2 squared plus 1 for x less than or equal to 2, and that will be 4x minus 7 for x greater than 2. So what we're going to do is we're going to solve this, but solve it as an equality, and then we're going to take a look and see how that relates to our inequality. So recalling that an equality is when we have an equal sign, and an inequality is when we have a greater than or a less than. So we're going to take both parts of the function bit by bit and solve what they would be for when they're equal to 28. So we first have that 4x minus 7 is going to be equal to 28. And that is going to be equal to 4x, and then we'll add 7 to both sides. So then 28 adds 7 is 35. Then dividing both sides by x, we have that x is equal to 35 divided by 4. And then likewise, for the other part of our function, so for the x less than or equal to 2 part, we're going to have x minus 2, let me square that, add 1 is equal to 28. So then multiplying these brackets out, we'll have x squared minus 4x, and then we'll add on 4 from doing negative 2 times negative 2, then adding 1 to that, we'll have plus 5 is equal to 28. And then we can subtract 28 from both sides, which leaves us with x squared minus 4x minus 23, and that shall be equal to 0. And then we can solve this using the quadratic formula. And we'll do this up here in this corner of the screen. So we have that minus b, so where a, b, and c are 1, minus 4, and minus 23 respectively. So we're going to have 4 plus or minus, then we'll have b squared minus 4ac inside a square root. So we'll have negative 4 squared. Then we subtract 4 lots of 1 multiplied by negative 23. Then we add our square root in here. And then we divide all of that by 2 of a, which is 2 times 1, which is 2. So therefore, putting this into our calculator, we have that x is going to be equal to 4 plus or minus the square root of 108 divided by 2. And then we put into our calculator the square root of 108, and we get that this is equal to 6 root 3. Then we have a 4 and a 6, which are being divided by 2, which, simplifying out, gives us 2 plus or minus 3 root 3. So we've now solved for our critical values, and we now need to look and see how this relates to the inequalities. So we first take a note that g of 35 over 4 is going to be equal to 28. And then if we then take our 35 over 4 and just make it a little bit larger. So let's have g of 35 over 4 plus 0.1. And then we'll be able to tell where the inequality holds and how it works. So that is going to be equal to, putting this into a calculator, recalling that 35 over 4 plus 0.1 is greater than 2. So we have 4 lots of this, and then subtract 7. And putting that into our calculator, we get that is 28.4, which is greater than 28. So therefore, we can say that for x greater than 35 over 4, that is a value for x of which g of x is greater than 28. So therefore, we know that for any x greater than this inequality here, g of x greater than 28, will hold. So we then have g of 2 plus 3 root 3. And we know that 2 plus 3 root 3 is going to be greater than 2. So we'll have that. So we know that 2 plus 3 root 3 is greater than 2. So we'll have that g of x is going to be 4x minus 7. And then substituting this into our equation, 4 lots of 2 plus 3 root 3 minus 7, we get that that is 21.7 0.78, which is not equal to 28, which tells us that x equals 2 plus 3 root 3 is not a solution or a critical value. So that means we need to do no further work to find that on the inequality. So then our next step will be to take a look at g of 2 minus 3 root 3. And we know that 2 minus 3 root 3 is going to be less than or equal to 2. So we'll have that g of x is going to be equal to x minus 2 squared plus 1. So then, just to double check this, if we take this and subtract 2 and square it, and then we add 1 on our calculator, we get that that is going to be equal to 28. So then, if we change this slightly and make it slightly more negative, so if we take 0.1 off of x, we'll then have g of 2 minus 0.1 minus 3 root 3. And putting this into our calculator, we have that that is equal to 29.05. And we can therefore see that that is greater than 28. So therefore, we know that g of x is going to be greater than 28 for all of x, which is less than 2 minus 3 root 3. So therefore, writing a concluding statement, we have that g of x is going to be greater than 28 for x less than 2 minus 3 root 3 and for x greater than 35 over 4. So in part C of this question, we're now given a function h, which is going to look familiar. It comes from part of our piecewise function from the previous part of the question with the function g of x. So we have now that h of x is equal to x minus 2 squared plus 1 for x less than or equal to 2. And we're to explain why h has an inverse, but g does not. So we're first just going to note down that h is 1 to 1. And that means it has an inverse. And how do we know this? So we know that h is going to be everything on the left side of the graph from the point where x is equal to 2. So x is equal to 2 here. So we know that h of x is going to be this part of the graph here. So I'll just label that on the graph h of x. And we know that a function is going to be 1 to 1 if by using the horizontal line test. So if I draw this horizontal line here, we can see that for h of x, so this yellow highlighted black line, that this purple line here is only ever going to cross this function h of x once. So therefore, we know it's 1 to 1 and it has an inverse. So writing that down, we say that h is 1 to 1, so it has an inverse by horizontal line test. And I'm putting in brackets there, the line A only cuts h of x once, hence it's 1 to 1. And then we can say on the other hand that g is many to 1. And this means it does not have an inverse. And how do we know this? Well, we know that g of x is going to be this whole curve here. And we see that it is intercepted by this line, which we've labelled A. It's intercepted not only here, but here as well. So therefore, writing that down, we have that it's not going to have an inverse and it's many to 1, since the line A intercepts the curve g of x at more than 1 point. So therefore, we've answered the question and explained why h is an inverse, but g does not. So for part D of this question, we're asked to solve the equation the inverse of h of x is equal to negative a half. So let's recall that we have that h of x is equal to x minus 2 squared, and we add 1 to that, and that is for x less than or equal to 2. So we know that if we have the inverse of functions, if we have, let's just say, for example, we have a function f, and its inverse, the inverse of f of x, is equal to a, then we know that x, since it's the inverse, is going to be equal to g of a. So therefore, in our case, we have that h, the inverse of h of x is equal to negative a half. So therefore, using this rule that we've just written down here in purple, we'll have that x is going to be equal to h of negative a half. And we know what h is, because we've just, we've been given that, we've written it down here. So this means that we can say that x is going to be equal to, subbing in negative a half into our equation for h of x, we'll have negative a half, then we subtract 2 and we square that, we add 1, and then putting this into our calculator, we have that this is 29 over 4, so therefore in decimal form we have that x is going to be equal to 7.25, and we have solved this equation and given a value for x. So now we're going to take a look back and see where we picked our marks up in this question. So part A of the question, where we had to find the value of g of x, so using composition of functions, it was worth 2 marks. We received our first mark for doing the initial function, so working out that g of 0 was equal to 5, and we then received our second mark for following this through and taking this value and substituting it into the next part, and our second mark is awarded for concluding that g of 0 is equal to 13. We then have that part B of the question was worth 4 marks. We received our first mark for knowing to work out the critical values, and we get our first mark for doing either 4x minus 7 is equal to 28 or x minus 2 squared plus 1 is equal to 28. That's 2 options to get our first mark. And we then receive our second mark for successfully working out the solution of 1x. So here I would pick up my second mark either here or either here also. I then receive my third mark for working out the second x value correctly. So if I receive my second mark here, I will then receive my third mark here, and then I receive my fourth and final mark for this working here, for coming to the conclusions about what the inequality is going to be. So here and here is where I pick up my fourth and final mark. Then moving to part C of the question, there was only 1 mark on offer, and you received that 1 mark for just this statement here, so stating that h is 1 to 1 and stating that g is many to 1. So then looking at question D, there was 3 marks on offer. We receive our first mark for knowing that we can work out x by substituting negative 1/2 into h. So I receive my first mark here. I receive my second mark for substituting this value into this equation for h. And then I receive my third and final mark for the correct conclusion that x is equal to 7.25. So in this question, we're told that a small factory makes bars of soap. And on any day, the total cost of the factory, which is in y pounds, of making x bars of soap, is modelled to be the sum of 2 separate elements. So it has a fixed cost, and then a cost which is proportional to the number of bars of soap that are made that day. And in part A of this question, we're asked to write down a general equation linking y and x for this model. So effectively, we're going to have an equation which shows the total cost of the factory of how many bars of soap they make per day. So we know that we're going to have an equation which is y equals something. And we know we have two elements of this. We're going to have a fixed cost, which is something that is the same for if we make 1 bar of soap or if we make 20,000 bars of soap. And we know this is going to be a constant. So noting this down here, we'll have that a fixed cost implies a constant, and then we'll have that a proportional cost, so the cost that is proportional to the number of bars of soap that are made each day. So we have proportional cost. That is going to relate to the number of bars of soap made. So we know that we're going to have an equation y equals, and then we're going to have an x variable somewhere, plus a proportional constant and a fixed constant. So we can put in our proportional constant, and it is proportional to x, and then we add in c, which is our fixed constant. So then just labeling this here, we'll just put a little annotation in to make things slightly clearer for us. We have that c is going to be the fixed, and that k is going to be the proportional constant. In this part of the question there was 1 mark available, and we received our 1 mark for stating the correct equation here. We're then given some further information, and we're told that the bars of soap are sold for £2 each. And we're told that on a day where 800 bars of soap are made and sold, the factory makes a profit, so a profit of £500. And on a day when 300 bars of soap are made and sold, the factory makes a loss of £80. And we're asked to use this information to show that y is equal to 0.84x plus 428. So this means we have two pieces of information which we can use to help us get to this point here. So let me just put a number I down here, and we're going to have that y, so the total cost is going to be the amount of bars we make multiplied by the cost of each one. So that's going to be 2 multiplied by 800. And then when we have 800 bars of soap, we know that there is a profit of £500. So we subtract 500, which then will give us the total cost. So then following this sum through in our calculator, we'll have 1600 minus 500, which is 1100. So this means that we now have an x coordinate and its corresponding y coordinate. So just write this like this: xy is going to be equal to 800 and then 1100. And then doing this for our second piece of information here, just doing the same thing, we have each bar of soap is sold at £2, we have 300, and we can work out the total cost by this time adding on the loss, since it's obviously a negative, so we therefore add it on. So that's 2 lots of 300 plus 80, and putting this into our calculator, this comes out as 680. So likewise, we can say that the coordinates x, y are going to be 300 and then 680 for the y coordinate. So then we remember back to our original kind of equation that we set up in part A of the question with our constants k and c. So this time for I, we're going to have 1100 is equal to 800k plus c, and for I, so our second piece of information, we're going to have that 680 is equal to 300k plus c. So all we've done is substitute x and y into our equation from part A, and we'll just write this on the side here just so we remember what it was. It was y is equal to kx plus c, and that, recall, was from part A of the question. So then we have substituted our values into this here, And what we now have is we have two equations with both with K and a C. So we can solve these simultaneously. So we rearrange to have that C is going to be equal to 1100 minus 800k. And for our second equation, we have that C is going to be equal to 680 minus 300k. And what we now do, we then equate these because we have something equal to C and something equal to C, which means that this is going to be equal to this. So we'll have 1100 minus 800k, and that is going to be equal to 680 minus 300k. And then we rearrange this and we have that 500k. So we've added 800 to both sides, and then that is going to be equal to 1100 minus 680, which is 420. So we now have this equation here, 500k is equal to 420. And what we'll then do with that is divide both sides by 500, and then putting into our calculator 420 divided by 500, we have that k is going to be equal to 0.84. And what we can then do is we take our equation for C. So we take this equation here, and then we have that C is equal to 1100 minus 800 lots of k, and we've just worked out what k is. So we substitute that in and have 0.84, and then putting that into our calculator, this comes out as 428, and that is equal to C. So then what we can do is we can go back to our original equation, y is equal to kx plus c, and we substitute our values for k and c in, and we have that y is equal to 0.84x plus 428, and this is what the question asked for, so as required. This question was worth 3 marks, and we pick our first mark up for correctly calculating both of the coordinates, so that using the x coordinates and this equations here to calculate the y coordinates. We then receive our second mark for correctly working out what k and c are, so the second mark is awarded here, and then we receive our third and final mark for coming to the correct conclusion and relating it back to the question. So now taking a look at part C of this question, we're asked with reference to the model to interpret the significance of the value 0.84 in this equation. So we recall what was the equation we're talking about. So it's the equation which we've just proven in the previous question, and just noting it down here in purple, we have that y is equal to 0.84x plus 428. So we recall that 428, that was a fixed cost. So there would be a cost of £428 if we made 0 bars of soap, or if we made 1 million bars of soap. So it's a standard cost which is fixed and it's always going to be there. And then we have that 0.84 is a cost that is proportional to the number of bars of soap that are made that day. So in practice, what does this mean? So this means that for each bar of soap extra that we make, there will be a cost of £0.84. So in other words, for every additional bar of soap we make, it will be 84p more expensive. So writing this down, we have that 0.84 is the cost of making each additional or extra bar of soap. In this question, there was 1 mark available, and we receive it for writing down 1 correct conclusion. For part D of the question, we are told to assume that each bar of soap is sold on the day it is made. And we're asked to find the least number of bars of soap that must be made on any given day for the factory to make a profit. So we're going to start by letting n be the least number of bars required to make a profit. Then what we can say is that 2n is going to be equal to 0.84n plus 428. And then dividing both sides by 2, we'll have that n is going to be equal to 0.42n plus 214. And then we can rearrange this equation to solve for n. So subtracting 0.42n from both sides, we'll have that 0.58n is going to be equal to 214. And then now dividing both sides by 0.58, we have that n is equal to 368.965. And we're asked to find our answer to a bar of soap, and we aren't dealing with decimal bars of soap, we're dealing with full bars of soap. So we therefore round this to the nearest whole number, which is 369 bars. So there was 2 marks available in this question, and we receive our first mark for knowing to make 2n equal to our equation from the previous question. Then we receive our second mark for concluding with the correct number of bars of soap, which was 369 bars. So in this question, we're being asked to find the value of the infinite sum from r equals 4 of 20 multiplied by a half of r. So we need to think, what do we know? We know that the infinite sum, which is sometimes denoted by this, or by this sigma notation here, is going to be equal to a, and we divide that by 1 minus r. This is a formula that you should be familiar with. So we know that a is the first term of the sequence of numbers, and that r is the common ratio. So to work out what a and r are, we're going to write out the first few terms of our sequence. So we'll say that our sequence is equal to 20 multiplied by a half to the power of 4 plus 20 multiplied by a half to the power of 5 plus 20 multiplied by a half to the power of 6, and then this goes on and on and on infinitely. And what we're asked to do is to find what the sum of all of these terms to all the way to infinity are added up. So we can see here, what is our first term? So the first term of our sequence is simply just going to be the first thing we write out for our initial value of r. So that's going to be 20 multiplied by a half to the power of 4. So we can write it down here, a is going to be equal to 20 multiplied by a half to the power of 4. And then what is r? So r is the common ratio. The way we can work this out is by looking at what changes each time we increase the value of r and move up a step in our sequence. All that's happening is we're increasing the power of r by 1. We go from 4 to 5 to 6 and so on. So this means that the common difference is 1/2, as this is what is inside the brackets, which is to the power. So we therefore have the values we need, and we can use this formula here to work out the answer. So we'll have that the infinite sum from r equals 4 to infinity of 20 multiplied by a half to the power of r is going to be equal to 20 multiplied by a half to the power of 4. And then our denominator is going to be 1 minus a half. And putting this into our calculator, this comes out as 5 over 2, which is equal to 2.5. There were 3 marks on offer in this question. So we receive our first mark for working out the values of a and r. We then receive our second mark for substituting them into the formula here, and we receive our third and final mark for coming to the correct conclusion of 2.5. So for the second part of this question, we're asked to show that the sum from n equals 1 to 48 of log base 5 of n plus 2 over n plus 1 is equal to 2. So we have to think, what's the best first step to help us be able to solve this? So we know that we have log laws. When we have log of something over something, so a fraction, we can split this into log of a minus log of b, where a is the numerator and b is the denominator. So we'll go ahead and do this here. Nothing changes with our sum, so it stays the same. But then what we can do is we can use log laws to split our log term up. So we'll have log base 5 of n plus 2, and then we subtract log base 5 of n plus 1. So then what we can do is we can write out our first few terms. So this is all going to be equal to, starting at 1, log base 5 of 1 plus 2, which is 3, plus log base 5 of 2 plus 2, which is 4. And then we go so on and so forth, and we come to the final term, n is equal to 48, and we know that 48 plus 2 is 50, so that's going to be log base 5 of 50. And then what we're going to do is put square brackets around these, and then we subtract, and we do the same for our other term. Then we have n equals 1, and 1 plus 1 is 2, so log base 5 of 2 plus log base 5 of 3, and then so on and so forth all the way to 48 plus 1, which is 49, so we have log base 5 of 49. Then we close our big brackets. So now think, what do we notice here? So this second term here on the second square brackets, so the whole term, this is going to have a lot of similar terms to this first term. So this goes from 2 all the way to 49, and this goes from 3 to 50. And we know that we're subtracting everything in these big brackets here. So this means that a lot of things are going to cancel out. So this log 5 base 3 will cancel out, or we then subtract log 5 base 3 here, and then that'll be the same for 4, and then so on and so forth. We'll have on the left hand side log base 5 49. That will then cancel out with log base 5 49 on the other side. So then this leaves us with only two terms. What we'll have is we'll have log base 5 of 50, because there is no 50 on the subtraction side, and then on the subtraction side we'll only remain with log base 5 of 2, and that's because there is no log base 5 2 on the left hand side here. So rewriting this, we then have log base 5 of 50, and then we're going to subtract log base 5 of 2, and then we still have our log law. We can now reverse the log law here and do what we did here, but in reverse this time. So we'll have log base 5 50 over 2, log base 5 50 over 2, and that is equal to log base 5 of 25. We then put log base 5 of 25 into our calculator, and we see that that is equal to 2. Now going back to the question, we were asked to show that this expression, this sum expression, was equal to 2, and that's exactly what we've done. So we'll therefore write a concluding statement, and we'll say that the sum from n equals 1 all the way to 48 of log base 5 n plus 2 divided by n plus 1 is equal to 2 as required And that's us completed this part of the question. And on the second part of the question, there was 3 marks available. We receive our first mark for using the log laws. We then receive our second mark for writing out all of the terms and then having a think about cancelling them out. And then we receive our third and final mark for coming to the correct conclusion. So in this question, we're told that a research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. We're told that the engineer measures and records the braking distance, which is measured in meters and denoted by D, and that's the distance when the brakes are applied from a speed denoted by V, which is measured in kilometers per hour. We are given in figure 5 and figure 6, we're given the graphs of V against D and of log base 10 of D against log base 10 of V. And we can see here in figure 5, we have this curve and we see it passes through the point 30, 20 here. And then in figure 6 on the right hand side, we can see that if we take log base 10 of both sides, we have a straight line, which has y-intercept negative 1.77. And what we are asked to do in part A of this question is to explain how figure 6 would lead to the engineer to believe that the braking distance should be modelled by the formula d is equal to kv to the power of n, where both k and n are constants, and we're told that k is approximately 0.017. So given that d is equal to kv to the power of n, and we're told that k is approximately 0.017. So essentially what we're being asked to do is we're being asked to make a link between this formula here and figure 6. And we recall in figure 6 we had axis like this, where we had log base 10 of V plotted against log base 10 of D, and we had a straight line a bit like this. So that was a kind of general idea and a miniature sketch of what we had. So to go from this equation here into a form where we can link it to the figure, which was log base 10d against log base 10v, what we're going to do is we're going to take logs of both sides. So that means we'll have log base 10 of d is going to be equal to log base 10 of kv to the power of n. But what we can do, we know our log laws, and we can use log law number 1 here, in this case here, where a is equal to k and b is equal to v to the power of n. So that is going to equal to log 10 of k, and then we add the same log base 10, so log base 10 v to the power of n. And then we notice we can use our second log law here and take our exponent, in our case n, and place it in front of the log term. So continuing this on, we'll have log base 10 of k, and then we add on to that n log base 10 of v, and we know this is equal to log base 10 of d. So then the next thing, we recall that we're told in the question that k is approximately 0.017. So what we can do is we can substitute this in to this position here. So we'll then have that log base 10 of d is going to be equal to log base 10 of k, so we'll put in 0.017 plus n log base 10 of v, and then putting into our calculators we have the log base of 10 of 0.017, that is going to equal negative 1.7695 and so on. So then rounding that to 2 decimal places, we can say that log base 10 of d is equal to n log base 10 of v, and then we take away 1.77, where our negative 1.77 comes from here. So what do we have now? Well, we have something that has the components of our graph. So we recall that we had log base 10 of d against log 10 of v. So if we think of a normal graph where we have y against x, so if I just draw in purple on our little graph at the top, y against x, we can then see that we have something very similar. So if I then write y is equal to mx plus c, we can see that in this case, this is the equivalent to the equation of a straight line, where we have y is going to be equal to log 10 of d, where we have m is going to be equal to n, and then our x is equivalent to log base 10 of v in our case, and then we have the y-intercept, which is usually denoted by c, and it is negative 1.77. And from the sketch in figure 6, we know that the y-intercept is negative 1.77. So therefore, we have the linear nature of this coupled with the y-intercept, which tells us that figure 6 would lead the engineer to believe that the braking distance can be modelled by this formula here. And we've just manipulated it to show that. And writing this down, the linear nature and y-intercept in the equation matching that of figure 6 tells us that the braking distance can be modelled by d is equal to kv to the power of n. So in this part of the question, there was 3 marks on offer, and we received our first mark for successfully working out what the value of k was, and we receive our second mark at this stage here, where we write out the equation in terms of log base 10 of d and log base 10 of v. And then we receive our third and final mark for this concluding statement down here in the corner. So in part B of this question, we're told to use the information given in figure 5 with k equals 0.017, and we're asked to find a complete equation for the model giving the value of n to 3 significant figures. So we recall we'll have the following formula where the distance d is modelled by 0.017 multiplied by v, which is the speed, to the power of n, where n is a constant, and we're told to use the information given in figure 5. So taking a look at figure 5 just here in the corner, the main piece of information which we can read from this is the coordinates at a certain point. So we know that when x is equal to 30, y is going to be equal to 20. So therefore, we're going to substitute these into this equation. So writing this down, for the coordinates 30, 20, we'll therefore have that 20 is going to be equal to 0.017 multiplied by 30 to the power of n. So what we now need to do is solve for n. So making this slightly simpler, we can say that 30 to the power of n is going to be equal to 20, and we divide by 0.017, and this isolates 30n, and what we're now going to do is take log base 10 of both sides, which will mean we can then use the log law. Log a to the power of m is equal to m log a, where we take the exponent in front of the log term to then isolate n. So writing all this down, we'll then have that log base 10 of 30 to the power of n is going to be equal to log base 10 20, and we divide that by 0.017, and then we can use our log law, which I will write down here again just in case we've forgotten, where we have log a to the power of m is going to be equal to m log of a. So we can use this here to bring the exponent n in front of the log base 10 of 30. So then what we'll have is n multiplied by log base 10 of 30, and that's going to be equal to this term here, which remains the same. And then all that's left for us to do is to now divide both sides by log base 10 of 30, which can be written as follows, and we'll not simplify any of the log terms at the moment, as we're just going to put them into our calculator once we've written it out. 0.17, and we divide all of that by log base 10 of 30. And putting this into our calculator, it comes out as 2.07876. And recalling the question, we're asked to give a value of n to 3 significant figures. So therefore, we can say that n is going to be equal to 2.08. And then we look back at the question where we're asked to find a complete equation. So this then means we rewrite our equation but substitute n in. So therefore we'll have that d is equal to 0.017 multiplied by v to the power of our new value of n, which is 2.08. And there we have the complete equation for the model. So in this question, there was again 3 marks on offer, and we received our first mark for substituting in 30/20 into our expression for the distance, and we then received our second mark for carrying through the working and rearranging to solve for n, and saying that n is equal to 2.08, and then we received our third and final mark for rewriting our equation but with our new value of n substituted in. Then in part C of this question, we're given some further information. We're told that Sean is driving this car at 60 kilometers per hour. And we have wet conditions, and Sean notices there's a large puddle in the road, and it's 100 meters ahead, and it takes him 0.8 seconds to react before applying the brakes. And we were asked to use our formula to find out if Sean will be able to stop before reaching the puddle. So we recall our formula from the previous question, where we have d is equal to 0.017 multiplied by v to the power of 2.08. So we know that he will be able to stop before reaching the puddle if we work out that the distance travelled is less than 100 meters. So we know that the distance will have 2 components. So the distance will be made up of the before brakes plus the after brakes distances. So we know that once he notices a puddle, it takes him 0.8 seconds to react. So this means that in those 0.8 seconds, the car will still travel a certain distance, which has to be taken into account. This is the before brakes time. And then the after brakes time is where we use the model to calculate this distance. So firstly, we can calculate the before. So just noting this here, before brakes. So we'll have that the distance, so we'll note this as distance 1, and that is going to be worked out using speed multiplied by time. And we know that the speed of the car is 60 kilometers an hour, and then we want to multiply this by the time. But we know that the time is 0.8 seconds. But to convert this into the same units that the speed is measured in, which is kilometers per hour, we must change the seconds into hours. So we can do this by dividing 0.8 by 60 squared. So that's going to be 0.8 over 60 squared, which is 3,600, and that's going to be in hours. So therefore, we'll substitute this into our equation, and we'll have 60 multiplied by 0.8 divided by 3,600. And putting this into our calculator, this comes out as 0.0133. And we note that this is going to be in kilometers, but we're dealing with meters. So to get this into meters, we multiply by 1,000, which implies that the distance before the brakes are applied that the car covers is going to be 13.3 meters. So now we need to use our equation here to work out what the second distance is. So the distance after the brakes are applied, we'll denote that by d2, and it can be calculated using our model, where we sub in our speed v. So this is going to be 0.017, and we know now that v is 60, and we have that 60 goes to the power of 2.08, and putting this into our calculator, this comes out as 84.9 meters. So therefore, the total distance is going to be equal to 84.9 plus 13.3, which, putting this into a calculator, this is equal to 98.2 meters, which means we can conclude that Sean stops in time. So in this part of the question, there was again 3 marks on offer. We receive our first mark for working out the distance using our model, where we substitute 60 into our formula. So we receive this at this point here, where we worked out d2. So we then receive our second mark for working out the distance before the brakes were applied. So that came when we worked out 13.3 meters. So we then receive our third and final mark for concluding that Sean stops in time and that the total distance is 98.2 meters. So in this question, we're given figure 7, and it's a sketch of a triangle OAB. And we're then given some information here, which is about various points, and we'll come back to this in a minute as we want to copy a diagram down and annotate it to help us move forward with the question. So we first note that question A is asking us to find the vector CM in terms of A and B. So as I said, the first step here is going to be to annotate the diagram. So we're told that the point C is such that the vector OC is going to be 2 lots of O to A. So we know here we have O to A, and then we know that this is going to continue to extend, and that will be our point C. So drawing this on our diagram, maybe not exactly to scale, but it will give us a rough idea. We can then say that this is going to be point C, and then the next thing we're given, we're told that the point M is going to be the midpoint of A and B, which we know will be around here. So then just dotting this on here, like that would be the midpoint M. And then thirdly, we're told that there's a straight line through C and M. So recall this is C and this is M. And this cuts the line O to B at the point N. So if we then drop a line down from C all the way to M, all the way to OB, we'll then have our point N. So as follows, we'll dot this down here. And then we have our point N. So now we have to have a think. What is the question asking us to do? So we're asked to go from C to M, and we're asked to write that in terms of A and B. So we're also told that O to A can be denoted as A, and that O to B can be denoted as B. So we now need to write the vector CM in terms of A and B. We first note that to get from C to M, we can go from C to A, and then we can add on A to M. So we can write this down. So we'll have that C to M is going to be equal to CA plus AM. So eventually we want to find this vector CM in terms of A and B. So we now need to have a think. How can we convert CA into something to do with A? We know that this distance here is going to be equal to this distance here. So to go from C down to A, it's going to be negative A, as this is just an extension of that line. So we'll take a note of this down here. So we'll have that CA is going to be equal to negative O of A, which is going to be equal to negative A. And then taking a look at AM, so recall this is this point here, we know that M is the midpoint of A and B, and we know that we can get from A to B by going negative A and then adding on B. So this means that we can go from A to M, bear in mind that M is the midpoint, by going from half of A plus B. So therefore, writing this down too, we have that A to M is going to be equal to 1/2 of negative A plus B. And what we can now do is substitute these important values here back into our equation for C to M. So this will be negative A plus 1/2 of negative A plus B. And then all that's left for us to do now is to tidy things up with our brackets. So we'll have still negative A, then we'll subtract 1/2A, and then we'll add on 1/2 of B. So then we further tidy this up, and we get that the vector Cm is going to be equal to negative 3/2 lots of A plus 1/2 of B. There were 2 marks available for this question, and we got our first mark for getting to this stage here, where we got Cm into an equation in terms of A's and B's, and we then receive our second mark for getting this into the form of the correct answer. So now moving on to part B of this question, we're asked to show that the vector ON is equal to 2 minus 3/2 lambda A plus 1/2 lambda B, where lambda is a scalar constant. So we first need to have a think. What is O to N and how are we going to get there? Well, we know that we can do this by going from O to C and then from C to N. And this is going to make it easy to break it down into A's and B's because of the work we've done previously. So noting this down, we have that the vector ON is going to be equal to OC plus Cn. And now we have to break it down a little bit more and look to see what this really means. So we first want to express OC in terms of A. So we recall that OA is A, so therefore OC is going to be 2 of A, given the information we were given at the start of the question, such that OC is equal to 2OA. So therefore, we have that the vector OC is going to be equal to 2A, and we'll then have that Cn, the vector Cn, is going to be equal to, well, let's have a think. So we can see Cn here, and we already know, and we've already worked out what C to M is in terms of A and B. We did this in part A of the question. So we know that C to N will be an extension of C to M. So therefore we can use lambda as a scalar value to say that the vector Cn is going to be equal to lambda C of M. And we know that the vector Cm is equal to negative 3/2 A plus 1/2 B. We know this from the previous question. So therefore we can substitute this into our expression for ON. So we'll have 2A plus this expression here with our lambda. So lambda multiplied by negative 3/2 A plus 1/2 B, and we put brackets in here. So the next stage for us is going to be to expand these brackets, and effectively we now need to simplify to collect our like terms. So we'll have that the vector ON is going to be equal to 2 lots of A and then we subtract 3 over 2 lambda A, and then we're going to add on 1 over 2 lambda B, and then now we can collect the A terms here, so we can then say that the vector ON is going to be equal to 2 minus 3 over 2 lambda, where we've taken out a common factor of A, and then we add on 1/2 of lambda B, and then looking back to the question, this was the required result, so as required. This question is worth 2 marks. We achieve our first mark for introducing lambda at this stage here. So where we said that C of n was equal to lambda C of m, and we receive our second mark for coming to the correct conclusion and stating that the vector ON is equal to 2 minus 3 over 2 lambda A plus 1/2 of lambda B. So moving to the third part of this question, we're asked to prove that the ratio between the vectors ON and NB is equal to 2, 1. So effectively what this is saying is that we want to prove if the vector NB is equal to 2 lots of the vector ON. So taking a look at our diagram, we see that the vector ON is here and the vector NB is here. So we can roughly see to the eye, remember this diagram isn't drawn to scale, but we can roughly see that this could well be true. We can have, say this length OB was 3 units, then ON would be 2 units and NB would be 1 unit. This is what we've been asked to prove. So we can start off by taking the A component of our vector ON. So this was 2 minus 3 over 2 lambda, and we're going to set this equal to 0. And now we're going to solve for lambda. So therefore we'll have that 4 is going to be equal to 3 lambda, so therefore lambda is going to be equal to 4 over 3. So for the next part of this question, we take the B part of our vector, and we have that O of n is equal to 2 over 3 of B. So then this means that the vector n to B is going to be equal to 1 over 3 lots of B. So therefore, we have shown that ON and NB have ratio 2 to 1 as required. This part of the question was worth 2 marks, and we received our first mark for working out that lambda was equal to 4 over 3, and we then received our second mark for concluding with the correct answer. So in this question we're shown figure 8, and that's a sketch of the curve C with equation y is equal to x to the power of x, and we can see it is shown as a curve in the graph here. So in part A of this question, for 5 marks, we're asked to find, and initially we're told to take logarithms, the x coordinate of the turning point C. So we know that y is equal to x to the power of x, and we have to have a think. We're told we're to find the turning point. So when we have a think about turning points, the first thing that comes to mind when we want to find a turning point is finding the derivative and then setting it equal to 0. So that's going to be our kind of plan of attack here for this question. But first, like the question says, we're going to take logarithms of both sides. So we have y is equal to x to the power of x here, and then writing underneath we're going to now have ln of y is equal to ln of x to the power of x. And then we have our log laws, and what we know is that if we have ln of a to the power of m using the exponent log law, this will then be equal to m multiplied by ln of a. So this means we can use this log law to help us with this question, and we can rewrite this right hand side taking the exponent x in front of the log term. So we'll therefore have that ln of y is going to be equal to x multiplied by ln of x. And then what we can do now, we can differentiate both sides. So we know that ln y differentiates to 1 over y. So therefore we'll have 1 over y and then dy by dx. And then on this other side here, we're going to use the product rule to differentiate this. So product rule, if we have that h of x is equal to f of x multiplied by g of x, then we'll have that the derivative of h of x is going to be equal to f dash x multiplied by g of x, and then we add on f of x multiplied by the derivative of g. So in our case, we'll have x and we'll have ln of x, and we know that x will differentiate to give 1 and ln of x will differentiate to give 1 over x. So therefore, using the product rule, we can then use these values here where x is f of x and g of x is ln x, and substitute them into this product rule here, and this is going to give us our answer up here. So we will have x multiplied by 1 over x, and then we will then add ln x multiplied by 1. So tidying this up, we'll have that 1 over y dy by dx is going to be equal to x multiplied by 1 over x, so those x's cancel out, so that will be equal to 1, and then we will have plus 1 multiple of ln of x, which is ln of x. And then one thing that we have said at the start already, we want to set dy by dx equal to 0. So then setting dy by dx equal to 0, we'll have 1 over y multiplied by 0 is equal to 1 plus ln of x. And then we know when we multiply something by 0, it is just 0. So we'll then have that 0 is equal to 1 plus ln of x. And then we can rearrange this to have the ln of x is going to be equal to minus 1. And then now we can take exponentials of both sides, and we know that when we have the exponential and the log term, they'll cancel out, which leaves us with x is equal to e to the power of negative 1, which is the same as 1 over e, and that is also equal to 0.368 when we put that into our calculator and round to 3 decimal places. So in the question we were asked to find the x coordinate of the turning point of C, and we have found that here, and it is equal to 1 over e, which is approximately 0.368. So this question was worth 5 marks, and we receive our first mark for taking logarithms of both sides using the exponential log law to get to this stage here, where we had ln of y is equal to x multiplied by ln of x. We then received 2 marks for getting to the stage where we took the derivative of both sides, and that was saying that 1 over y multiplied by dy by dx is equal to 1 plus ln x. We then receive our 4th mark for manipulating this and setting it equal to 0 and getting to the stage where e ln of x is equal to e negative 1. And then we receive our 5th and final mark for coming to the correct conclusion and having the correct answer that x is equal to 0.368 or 1 over e. So in part B of this question, we're told that the point P, which has x coordinate alpha and y coordinate 2, lies at some point on the curve C. And we're asked to show that alpha, the x coordinate, is between 1.5 and 1.6. So first of all, we recall that the formula for a curve C is y is equal to x to the power of x. So what we're going to do is we're going to take these two values, 1.5 and 1.6, and substitute them into our equation for y. So for x equal to 1.5, we'll have that y is equal to 1.5 to the power of 1.5. And putting this into our calculator and rounding to 3 significant figures, this comes out as 1.84. And then likewise for x equal to 1.6, we have that y is equal to 1.6 to the power of 1.6. And this comes out as 2.12. So for the point P, which has coordinates alpha 2, we have that our y values when x is equal to 1.5 and 1.6 are 1.84, which is less than 2, and we have that 2.12, so our y value when x is 1.6 is going to be greater than 2. So we have that 1.84 is less than 2, and then we have that 2.12 is greater than 2. And we also know that C is a continuous curve. Hence, for these reasons, we can conclude that alpha is going to lie between 1.5 and 1.6, which is what the question asked us for. So there was 2 marks available in this question, and we receive our initial mark for substituting in both our values 1.5 and 1.6 into our formula and coming out with 1.84 and 2.12, and we then receive our second mark for stating this bit here about the y values being below and above 2, and then having a concluding statement and concluding the correct required form of alpha is between 1.5 and 1.6. So in this part of the question, we're given some further information, and we're told that a possible iteration formula that could be used in an attempt to find alpha is going to be x n plus 1 is going to be equal to 2 of xn to the power of 1 minus xn. And we're told that we have an initial x1, which is equal to 1.5, and we're to use this formula to work out what x of 4 is to 3 decimal places. We'll begin by taking our formula, and we can work out that x of 2 is going to be equal to 2 multiplied by x of 1 to the power of 1 minus x1, which is going to be equal to 2 multiplied by 1.5, and then that is going to be to the power of 1, take away 1.5. So we put this into our calculator, and this comes out as a number with lots of decimal places, and it goes like this: 1.63299 and so on. So then what we can do next is we know that x3 is going to be 2 multiplied by x2 to the power of 1 minus x2. So then rather than taking our value for x2 here, which if we were to round to say 3 decimal places would give us an inaccurate answer going forward, what we can do in our calculator is initially we will have put 2 multiplied by 1.5, but what we can do is we can use the answer button as our calculator stores this answer, and then this means that the calculator will use the full value of this for x2, and then if we do this once, this comes out as 1.46626 and so on. And we can then just press the answer button once more, which will give us the value of x4. So the formula stays the same, and then this comes out as 1.6731 and so on, and we're asked to work out x4 to 3 decimal places. So then we round this to 3 decimal places, which comes out as 1.673, and therefore we've answered the question. This question was worth 2 marks, and we receive our first mark for getting to this stage here where we've calculated x2. So this is when we've used our initial value x1 and substituted it into the iteration formula that we're given, and then we receive the second mark for following through with these other values and concluding that x4 is equal to 1.673. So in part D of this question, we're asked to describe the long-term behaviour of xn. So as n tends to infinity, what happens to the value of xn? So that's what the question's asking us. And what we can do is if we continue pressing the answer button on our calculator like we did to find x4 in part C of the question, we'll see that firstly, the value of x of n will stabilize and it will begin to fluctuate between the value of 1 and 2. So this means that it will be 1, then 2, then 1, and then 2, and so on. And this pattern will continue. And this also tells us that the behavior of xn will be periodic. So we'll have the xn will be periodic. And we have to think, what will the period be? So the period will be 2 because of the way it's oscillating. So with period 2. So this question was worth 2 marks, and we receive 1 mark for each statement we make here, which is about the periodicness and the fluctuation of x of n as n gets large. So in this question, we're asked to prove that cos 3 theta over sine theta plus sine 3 theta over cos theta is equivalent to 2 cot 2 theta. So to begin, the first step we're going to make is we're going to multiply out our fraction and we're going to get it into one big fraction with the denominator sine theta cos theta. So our first move here will be to multiply cos 3 theta by cos theta. And what we're going to do is we're going to work with this left hand side and work towards this right hand side. So therefore we have cos 3 theta multiplied by cos theta. Then we'll have sine 3 theta multiplied by sine theta. So that'll be plus sine 3 theta multiplied by sine theta. And then, as we know from multiplying fractions, we'll then have sine theta multiplied by cos theta as the denominator of this single fraction here. So then now we have a term with cos 3 theta and cos theta and sine 3 theta and sine theta. So we need to have a think about trig identities, and do we know any trig identities which we can use to help us? So we know, taking a note down here, that if we have cos of a minus b, then that is going to be equal to cos a multiplied by cos of b, and then we're going to add sine a sine b. So this right hand side here, cos a cos b plus sine a sine b, this is what we have here on the numerator. So we have that a is going to be equal to 3 theta and b is going to be equal to theta. So we can write this numerator as follows, where we have cos of a minus b, so that will be cos of 3 theta minus theta, and then we divide this by our denominator. It doesn't change, so that remains sine theta cos theta. And then we can tidy up this here in the numerator, and that will be equal to cos of 3 theta minus theta, which is cos of 2 theta. And again, the denominator stays the same, and that's going to be sine theta multiplied by cos theta. So our next step is to have a look at this denominator and see if there's anything we can do or anything we know which will help us here. So we know we have the double angle formula, which is as follows. It is sine 2 theta is going to be equal to 2 sine theta cos of theta. So what we have here, 2 sine theta cos theta, is very similar to what we have here as our denominator. So to make this the same, we need to get rid of the 2. How do we do that? We can divide both sides by half. So therefore, our trig identity which we're going to use is going to be a half of sine 2 theta is going to be equal to sine theta cos theta. So what we can then do is we can replace sine theta cos theta with 1/2 of sine 2 theta. So therefore, this is going to be equal to cos 2 theta. And we then divide by 1/2 sine 2 theta. So then now, we know that if we are dividing by 1/2, that is going to be equal to multiplying by 2. And then we know that when we have cos over sine, that is going to be equal to 1/tan. So in this case, our denominator here will become tan 2 theta. And we'll just note down here that cos theta over sine theta is equal to 1/tan theta. And then now we look back to what we're aiming for. We're aiming for 2 cot 2 theta, and we have 2/tan 2 theta. Well, we can also use the trig identity that cos theta over sine theta is equal to 1/tan theta, but we know that this is also going to be equal to cot of theta. So therefore, we can now use this last trig identity here, and we can conclude that this is going to be equal to 2 multiplied by cot 2 of theta. So therefore, write a concluding statement, we have shown that cos of 3 theta divided by sine theta plus sine 3 theta divided by cos theta is equivalent to 2 cot 2 theta. And this is what the question was asking for, so we'll write as required. And that's us completed the proof. So this question was worth 4 marks, and we received our first mark for multiplying out a fraction and getting it into one single fraction. We then received our second mark for using our first trig identity, so using the fact that cos of a minus b was equal to this term here, and then implementing that here. We then receive our third mark for knowing to use the double angle formula and getting to cos of 2 theta over 1/2 of sine 2 theta. And then we receive our fourth and final mark for going from this stage here to this stage here. So knowing that cos theta over sine theta was equal to cot theta. And then we pick this final mark up for concluding with a correct statement at the end here. So in part B of this question, we're asked to solve for theta, where theta is between 90 and 180 degrees. And we're solving the equation which we were presented with in part of the question, and we remember that it is cos 3 theta over sine theta plus sine 3 theta over cos theta, and we're making that equal to 4, and we want to solve for theta. So we remember what we proved in part A is that this expression here was equal to 2 cot 2 theta. So we know that we can then write this. So we'll have 2 cot 2 of theta is equal to 4. But then we know that 2 cot 2 theta is going to be the same as 2/tan 2 theta. And then this is something that we can use our calculators and our knowledge of trig to solve. So therefore, we'll just note down here that this is then going to be equal to 2 divided by tan 2 theta. So then going back to what we have, we can write that 2/tan 2 theta is going to be equal to 4. So we can then multiply both sides by tan 2 theta, which will give us 2 is equal to 4 tan 2 theta, and then we can divide both sides by 4. So this will give us tan 2 theta on its own. So we have tan 2 theta is equal to 2/4, and we know that that is equal to 1/2. And then this is something that we can use our knowledge of trig to solve. So we can then say that 2 theta is going to be equal to arctan, so tan minus 1 of a half, and this is something that we can put into our calculators. So we'll therefore have that 2 theta is going to be equal to 26.6 degrees, rounding to 3 significant figures. And then we'll use our cast diagram. So we draw that here, and we first tick the all box because we don't have a negative here, we have a positive, so we tick the all box, and then we're working with tan, so we tick the T box. So this means that we're going to have a second solution at 180 plus 26.6. So this means that 2 theta is also going to be equal to 206.6 degrees. So then we can now solve for theta by dividing everything by 2. So we'll have here with our first solution that theta is going to be equal to 13.3 degrees. And then we divide 206.6 by 2, which comes out as 103.3 degrees. And we remember in the question we were solving for theta between 90 and 180. So therefore we can say that 13.3 is not a valid solution because it's out of range. But we see that theta being equal to 103.3, that's a valid solution. So therefore we conclude that theta is going to be equal to 103.3 degrees. And we're asked in the question to give our solutions to 1 decimal place, and that's what we've done here with 103.3 degrees. So in this question, where were our marks available? So we achieved our first mark for getting to this stage here. So when we said that 2 over tan 2 theta was equal to 4. So basically, if we're using our knowledge of what we did in the previous part of the question, we can then pick up our first mark there. We then pick up our second mark for getting to the stage where we knew to do arctan. So where we had that 2 theta was going to be equal to tan to the power of minus 1, and then putting a half in. And we then receive our third and final mark for coming to the correct conclusion of 103.3 degrees, noting that 13.3 is out of range. So we need to remember this statement here, and then concluding with our value of theta, 103.3 degrees. So in this question, we're told that a manufacturer produces a storage tank, and the tank is modelled in the shape of a hollow circular cylinder, which is closed at one end, and at the other end it has a hemispherical shell. And we can see this in figure 9. So we see highlighted now is the hemispherical shell, and then highlighted now is the cylinder, the closed cylinder. So we're told that the walls of the tank are assumed to have negligible thickness, and the cylinder has radius of r meters and height of h meters, and the hemisphere has a radius of r meters. And we're given the information that the volume of the tank is 6 meters cubed. In this part of the question, we're asked to show, according to the model, that the surface area of the tank in meters squared is given by this equation here. 12 over r plus 5 over 3 pi r squared. So to begin, we must have a think about how will we work out the surface area. So taking note of that here, we note that the surface area of this will have multiple components. It will have the surface area of the cylinder, it will have the surface area of the base of the cylinder, and it will also have the surface area of the hemisphere on top. So writing this down, we can say that the surface area is going to equal area 1 plus area 2 plus area 3. And just for completeness, we're going to write down what area 1, area 2 and area 3 represent. So we have that the surface area of the cylinder is going to be denoted by A1. We have that the surface area of the base is going to be denoted by A2. and that the surface area of the hemisphere is going to be denoted by A3. So we now have a think, what is the surface area of a cylinder going to be? This is going to be 2 pi r multiplied by h. We know that the area of the base, the surface area of the base of the cylinder, is going to be pi r squared. And then for the surface area of the hemisphere, we know that a sphere has surface area 4 pi r squared, and we have half of that sphere. So therefore, the surface area of this hemisphere is going to be 4 pi r squared divided by 2, which is equal to 2 pi r squared. So then therefore, we can add all these together. So we have that the area is going to be equal to 2 pi r multiplied by the height plus pi r squared plus 2 pi r squared. So then we can just simplify this slightly. We see we have pi r squared and 2 pi r squared. So adding them together, we have that 2 pi r h plus, combining these, 3 pi r squared. So then we now look back at what we're aiming for. We're aiming for something here, but this is in terms of r. But then we have h. So this is where we must have a think. How do we get around this problem? So we're given the volume of the tank, and we know that that is equal to 6 meters cubed. And we know that this volume is going to equal the volume of the cylinder plus the volume of the hemisphere. And then we can work these out. So we know that the volume of a cylinder is going to be pi r squared multiplied by the height. And we know that the volume of a sphere is going to be 4 over 3 pi r cubed. And we have the hemisphere, so we again divide by 2. And this gives us that the volume of the hemisphere is going to be 2 pi r cubed divided by 3. And we know that this is equal to 6 because that's what we're given as the volume. So therefore, on this right hand side, we can take a common factor of pi r squared out. And that leaves us with h plus 2 over 3 r. And that's equal to 6. So we're then going to rearrange this for h. So then we divide both sides by pi r squared. And then to isolate h on its own, we must get rid of this 2 over 3r. And we're going to do this by subtracting it from both sides. So now we have an expression for h. And our expression for h is in terms of r. And this is good because we want to get our area expression in terms of r. So therefore, we can take this equation for h and substitute it in here. So therefore, going back up here, we're going to have that the area is going to be equal to 6 divided by pi r squared. Take away 2 over 3r. And we multiply this by 2 pi r. Then we add on our 3 pi r squared. And then multiplying out these brackets, we'll then have 6 times 2, which is going to be equal to 12 pi r divided by pi r squared. And then we have negative 2 over 3 r multiplied by 2 pi r, which is going to come out as negative 4 over 3 pi r squared, and then we add on our 3 pi r squared from before. So therefore, we can conclude that the area is going to be equal to, so we have pi r and pi r squared. So the pi's cancel out, and then we have r over r squared, which leaves us with 12 divided by r. And then we have 3 pi r squared negative 4 over 3 pi r squared, and this simplifies to 5 over 3 pi r squared. And then we take a look back at the question and see what it was asking for. It was asking for 12 over r plus 5 over 3 pi r squared, And that's what we have. So we write as required. And that's us completed this question. This question was worth 4 marks, and we receive our first mark for writing out the area as a sum of all the surface areas. So we receive our first mark at that point. We then receive our second mark for expressing our volume being equal to the volume of the cylinder and the volume of the hemisphere, and equating that equal to 6. So we receive our second mark here. We then receive our third mark for getting the correct expression for H, and then we receive our fourth mark for substituting that into our equation here and concluding with the correct answer as we have here. So in part B of this question, we're given some further information. We're told that the manufacturer needs to minimise the surface area of the tank. And we're asked to use calculus to find the radius of the tank for which the surface area is minimum. So we first recall that we have just shown the equation for the surface area of the tank, and that's given by 12 over r plus 5 over 3 pi r squared. So we know if we want to find a minimum, we're going to take our expression, we're going to differentiate it, and then our second step is going to be set equal to 0, and then our third step is going to be in this case we're working out to find the radius, so we will solve for r. So we have dA, and we're going to be differentiating with respect to r, and then we have that 12 over r, that is going to differentiate to minus 12 over r squared. And then our 5 over 3 pi r squared is going to differentiate to 10 pi multiplied by r over 3. We then set this equal to 0. And our first step is going to be to multiply both sides by 3. So this will then leave us with negative 36 divided by r squared plus 10 pi r, and that's equal to 0. And then we're now going to get rid of the denominator in this fraction, so we multiply both sides by r squared. So this leaves us with negative 36 plus 10 pi of r multiplied by r squared, which gives us r cubed, and that's still equal to 0. And then continuing this on, we shall add 36 to both sides. So this leaves us with 10 pi r cubed is equal to 36. And we now want to solve for r. So therefore we have that r cubed is going to be equal to 36 divided by 10 pi. And then we can isolate r by taking the cubed root. So we'll have 36 over 10 pi. And then we take the cubed root of that, and putting that into our calculator, we get 1.05 meters. So we can therefore conclude that the surface area will be a minimum when r is equal to 1.05 meters. So there was 4 marks on offer in this question. We received 2 marks for differentiating and setting it equal to 0. We then receive 1 mark for getting the correct r cubed expression here, and we receive our fourth and final mark for concluding with the correct answer of 1.05 meters. So in this part of the question, we're asked to calculate the minimum surface area of the tank, and we're asked to give our answer to the nearest integer. So we now have our value of r, for which the surface area will be at a minimum, and we know the expression for the surface area, which is in terms of r. So what we do here is we take our value of r and we substitute it into our equation for the surface area. So doing this here, we'll have 12 over 1.05, and then we will add on 5 over 3 multiplied by pi multiplied by 1.05 squared, and then we put this into our calculator, and this comes out as 17.201, and so on. So therefore, we then have that the minimum surface area is 17.201 meters squared. There were 2 marks on offer here. We received our first mark for knowing to substitute in a value of 1.05 into our expression for the surface area, and then we receive our second mark for concluding that the minimum surface area is 17 meters squared. So in this question we're asked to use the substitution u is equal to 4 minus the square root of h to show that the integral of 1 over 4 minus root h, integrating with respect to h, is going to be equal to negative 8 ln of 4 minus the square root of h, take away 2 root h plus a constant k. So to begin with, we're going to write down our substitution. So we'll have that u is going to be equal to 4 minus the square root of h. And what we're first going to do is we want to get this into a form where we have a du and a dh, which then means we can rearrange for dh and then substitute this in as such. So we differentiate and we will have that du is going to be equal to 4 differentiates to nothing, and we have that negative root h differentiating with respect to h is going to be negative 1 over 2 root h, and that is going to be dh. And therefore we can also rearrange this first line here, and we can write that the square root of h is going to be equal to 4 minus u. So now we want to rearrange this for dh, so we can therefore say that dh is going to be equal to negative 2 root h du. And we now, what we notice is we have an expression for dh, which can be substituted into our equation here. But then we also know what root h is in terms of u. So then we can rewrite our term for dh in terms of u. So we can therefore say that dh is going to be equal to negative 2 lots of root h, and we know that is 4 minus u, and that is going to be du. And then expanding those brackets, we have that dh is going to be equal to negative 8 plus 2u du. So we'll now take this expression here and substitute it in to our integral here, and we shall also take in this expression for h and substitute it in here. So we can therefore say that the integral of 1 over 4 minus square root of h with respect to h is going to be equal to 1 over 4 take away 4 minus u, and then we sub in our expression for dh, which is going to be equal to negative 8 plus 2u, and that's now our integral is with respect to u. So therefore we can tidy this up, and we see that we have 4 take away 4 plus u, so that is going to be u. So we're then going to have our numerator is going to be 2u minus 8, and we divide all that by u, and that's still with respect to u. And then we can simplify this by doing 2u divided by u, and then we have take away 8 over u, and it's still with respect to u. So now all that's left to do is to integrate. So we have that these u's cancel out here, so therefore we will have the integral of 2, and then we take away 8 over u, and what we can now do is integrate. So we know that 2 is going to integrate to 2u, and we have then 8 lots of the integral of 1 over u, and we know that that is going to be ln u. And then we add c as well. So now all that's left for us to do now is to then re-substitute in u in terms of h, because we know that the answer that we're required to show is in terms of h's, not u's. But that's not a problem, because we have u's in our equation, but then we also have an expression of u in terms of h. So therefore, substituting this back in, we'll have 2 lots of 4 minus the square root of h. And we'll take away 8 ln of the absolute value of 4 minus the square root of h, and then we still have our constant c on the end. So then the next thing we can do is expand these brackets. So we'll have 8 minus 2 root h, take away 8 ln 4 minus the square root of h, and then we add our constant c as well. So then now we can say that we have c plus 8 and let it be equal to a constant k. So then finally we can say, just going back to the question, we have that the integral of 1 over 4 minus the square root of h integrating with respect to h is going to be equal to negative 8 ln of the absolute value of 4 minus the square root of h, and then we subtract 2 root h and we add our new constant k, and that is the required answer which the question asked us for. So therefore we've completed this question. So this question was worth 6 marks, and we achieved our first mark at this stage here when we knew to differentiate and then rearrange for dh. We then receive our second mark for getting our integral into the form where we had 2u minus 8 over u, so essentially substituting in and tidying up a little bit. And we then receive our third mark for getting it into this form where we were ready to integrate. So when we had 2 minus 8 over u, we then receive our fourth and fifth mark for 1, knowing how to integrate, and then secondly, for integrating correctly. So that's at this stage here where we receive 2 marks, and then we receive our final 6th mark for coming to the correct conclusion which the question wanted. So in this part of the question, we're told that a team of scientists is studying a species of slow-growing trees. We're told that the rate of change in height of a tree in this particular species is modelled by the following differential equation. So we have that dh by dt is equal to t to the power of 0.25 multiplied by 4 minus the square root of h over 20. So we're told that h is the height in meters and t is the time, which is measured in years, and that is measured from the point of which the tree is planted. And what we're asked to do, we're asked to find, according to this model, the range in height of trees in this species. So firstly, so we know that when the trees stop growing, the rate of change of their height, so we know that is dh by dt, then in brackets, rate of change of height, is going to be equal to 0. So if we think about this, when the trees stop growing, it will no longer be changing, and then this means that this will be the point at which the trees are as tall as possible. So we know to do this, we can set our equation dh by dt equal to 0. So we have that dh by dt, which is equal to t to the power of 0.25 multiplied by 4 minus the square root of h, all divided by 20, is going to be equal to 0. So then rearranging this, we multiply both sides by 20, so we'll have t to the power of 0.25 multiplied by 4 minus the square root of h, that's equal to 0. And then bearing in mind we are solving for h here, so we can divide both sides by t to the power of 0.25, which leaves us with 4 minus the square root of h is equal to 0. So therefore we have worked out that the square root of h is going to be equal to 4. And then we can square both sides, so we'll have that h is going to be equal to 16. So then we're asked in the question the range of heights of trees in this species. So we've shown here that when the trees stop growing, they will be 16 meters. But then we know that some trees will be just planted, some trees will be new, and they will start at a height of 0 meters. So therefore, the range of heights of trees will be anything between 0 meters and 16 meters. So therefore we've found the range of heights of the trees in this species according to the model. So in this question there was 2 marks available. We receive our first mark for getting to the stage where 4 minus the square root of h is equal to 0. So that's effectively for knowing to set our rate of change equation equal to 0 and doing the first stage of rearranging. And then we achieve our second mark for getting to the correct answer of a range of heights of trees, and in this case it's when the height is between 0 and 16 meters. So in this question we're told that one of the trees is 1 meter high when it's first planted, and we're asked, according to the model, to calculate the time this tree would take to reach a height of 12 meters, and we're to give our answer to 3 significant figures. So the first step in this question is to separate the variables. So we have our equation dh by dt, and then we have on the right hand side a t variable and a h variable. So what we're going to do is we're going to get all of the h's on one side and all of the t's on the other side, and then that means we can integrate. So to get our h's on one side, we will divide both sides by 4 minus root h. So this leaves us with, and then we're going to integrate just after, so I'll put the integral symbol in. So this leaves us with 1 over 4 minus the square root of h, then our dh remains there. And then on the other side, we're going to have t to the power of 0.25 divided by 20, and we're multiplying both sides by dt, so we got our dt here, and then we'll put in our integral symbol here too. So the first thing we notice, the integral 1 over 4 minus root h, we know this from part A of the question, and then we're left to work out this here. So we know from part A of the question that 1 over 4 minus root h is going to be equal to negative 8 ln of 4 minus the square root of h, and then we have absolute value signs around that because it's a logarithmic term, and then we subtract negative 2 root h, and then in this case we don't really need to add the constant because we'll do that on the other side, because we only need to add one constant for our integration of both sides. And then we know that this can be equal to the integral here. So writing this at the side, we have that t to the power of 0.25 over 20, and we integrate that with respect to t. That is going to be equal to, so we add 1 to the power, so we'll have t to the power of 1.25, and then we divide by 1.25, so we'll have 1.25 multiplied by 20, and that is going to be equal to t 1.25 over 1.25 multiplied by 20. Putting that into our calculator, that comes out as 25, and then we'll add c. So therefore, writing this in back to our equation, we'll have t to the power of 1.25 all divided by 25, and then here is where we add c, and I'll put it in brackets for just now. So then we're told some information in the question. We're told that t is equal to 0 and the height is then going to be 1 meter. So we can use these two values to work out what c is. So therefore, with t equals 0 and h equal 1, we're going to have negative 8 ln of 4 minus the square root of 1, and then we take away 2 lots of root h, so 2 lots of the square root of 1, and that is going to be equal to 0 to the power of 1.25. We know that's going to be equal to 0, so that remains as c. And then simplifying this ever so slightly, we'll have negative 8 ln, then we have 4 minus the square root of 1, which is 3, and we know 3 is positive and nothing can change, so we can omit the absolute value signs, and then we have 2 multiplied by the square root of 1, which is 2 multiplied by 1, which is 2, and we have that that is going to be equal to c. So what we can do is we can now take this and substitute it back into this equation here. So just writing that down, substitute back in. So we're going to have negative 8 ln of 4 minus the square root of h, and we take away 2 root h, and this is going to be equal to t to the power of 1.25 divided by 25, and then we add c. We've just worked out what c is, so we substitute that in. So we have negative 8 ln 3 minus 2. We need to think back to the question, what are we trying to achieve? So we're asked to calculate the time this tree would take to reach a height of 12 meters. So we know that when h is equal to 12 meters, what is the time? So what we can do is we can take our new expression and substitute in h equals 12 and then solve for t. So we're going to have negative 8 ln of 4 minus the square root of 12, and we have our absolute value signs again, and then we take away 2 multiplied by the square root of 12, and then that is going to be equal to t to the power of 1.25 divided by 25, and then we take away 8 ln 3 and 2. So the next stage is for us to rearrange and to solve for t. So what we can do is we can take this term and add them onto the other side. So we're going to have negative 8 ln of 4 minus the square root of 12. Then we take away 2 root 12 also. 8 ln 3 plus 2. Then we're going to put these in brackets, because what we can do now is multiply both sides by 25. That's going to leave us with t to the power of 1.25. So then what we can do to get rid of the 1.25 is to take the root to 1.25. So we'll write this in here in green. So we're going to have the 1.25th root, and then putting this all into our calculator, we therefore have that t is going to be equal to 75. Then we round to 1 decimal place because we're asked for 3 significant figures. So t is going to be equal to 75.2 years when h equals 12 meters. And therefore we've finished the question. So in this question there was 7 marks on offer, and we achieve our first mark for knowing to set up our integrals and try to separate our variables. We then receive our second mark for attempting to integrate, and we receive our third mark for integrating correctly. So that's at this stage in the question here, where we receive 2 marks. So we then receive our fourth mark for getting an expression in terms of c, and that's at this stage here after we have substituted in t equal to 0 and h equal to 1. We then receive our fifth mark for getting to the stage where we substitute back in our value for c and get to this stage here. So that's when we took our newfound value of c and understood that that was to be substituted back in to our original expression. And then we receive our sixth mark for getting to this stage here, where we had an expression in terms of t. So this is when we had t to the power of 1.25, and we then went and solved that by taking the 1.25th root of it, and then we receive our seventh and final mark for concluding with the correct answer, which was 75.2 years.